Alright, today we started talking about interval notation. So if we first look at this chart, we have some examples. The first is written as an inequality, so it says x is greater than or equal to negative 3, but less than 5. So in interval notation, because it's equal to, we have a bracket, negative 3, 5, parentheses. So when we have less than, equal to, greater than, equal to, we're going to be using brackets. We have just less than or greater than, we're going to be using parentheses. Okay. Then if we go to our graph, it's in between negative 3 and 5. Okay. It's equal to negative 3, so that's a closed circle. And it's just greater than or less than 5, so it's an open circle. Okay, so those are just our hints to help us out from there. Alright. On example 2, we have x is greater than 2. So our interval notation is going to be from 2 to infinity, because it's all values that are greater than 2. So all the way to infinity. Then our graph, we start at 2 with an open circle and right arrow in the positive infinity direction. Okay, so if we look at the first one, I have x is less than or equal to 3. Okay, so let's go ahead and just graph that so we can see what that looks like. So I have 3. It's less than or equal to, and I'm going to have a closed circle. Okay, and I'm just going to put a couple numbers beside it. And if it's less than, I'm going to go in the direction to the left, because all those values are less than. So if we look, I'm going all the way in the negative infinity direction. So that's where I'm going to start, negative infinity. Okay. Then I stop, the highest value I can get is 3. Okay, and then I have brackets because it does include that number. Okay, if it was just less than 3, then it would be parentheses. Okay, let's look at number 2. So it goes from negative infinity to 4. Okay, that means all values smaller than 4. So x is less than 4. So if I were to graph this one, I'd have 4, an open circle going to the left. Okay, on number 3, it gives me the graph. If we see it's in between 2 and 6, okay, it equals on both, so I'm going to have 2, 6, less than or equal to x, less than or equal to 6. Okay. The reason the signs go this way is if we read from the x is greater than or equal to 2, but x is less than or equal to 6, which is true. It falls in between those two numbers. So on this, because they're both equal to, I'm going to have the brackets on both sides. Alright, let's go ahead and let's get down to number 6. We have x less than 1 or x greater than or equal to 5. Okay, that gives me two things. So I'm going to have two different intervals. So first is going to be from negative infinity to 1, parentheses, because it's just less than, or bracket 5 to infinity. Okay, so I'm going from negative infinity to 1, or I'm going from 5 to infinity. So on my graph I have 1 and I have 5. Okay, at 1 it's an open circle and it's less than. 5 closed circle, greater than. So it's either this situation or it's this situation. Alright, let's look at 8. X is any real number, so that means no matter where on my number line, it's going to be part of it. So this whole thing is part of it. Okay, so in both directions I'm going to negative infinity and then I'm going to positive infinity. So there, that just gives you an idea of that. Okay, now I'm going to flip this over and we're going to take do a couple examples that are going to be more like what's on your homework. If I have 8a minus 15 greater than 75, I'm going to solve this like I normally solve an equation. So add 15. So 8a is greater than 90. Okay, then from here, divide by 8. So A is greater than 11.25. Okay, then I need to graph that. So I'm going to start off 11.25. A number that's bigger than that is 12. A number that's smaller is 11. Okay, it's going to be an open circle going to the right. Alright, so there's that. That's good. Let's look at example 2. So I have 6 plus 5 times 2 minus x less than or equal to 41. Okay, first thing I would need to do is distribute. So I have 6 plus 10 minus 5x less than or equal to 41. Okay, I need to combine my like terms here, so that would be 16 minus 5x less than or equal to 41. Okay, solving this, I need to subtract 16 from both sides. So you get negative 5x is less than or equal to 25. Okay, here's the thing that you need to remember when we divide by this negative. Okay, anytime you divide or multiply by a negative, you need to flip the sign. Flip your inequality sign. So this now becomes x is greater than or equal to negative 5. Okay, if you don't flip your sign, then your answer is not going to be correct. So when we graph this, start off at negative 5. A number bigger is negative 4. A number smaller is negative 6. We're going to have a closed circle going to the right. Alright, so again, the key thing here is when you're dividing and multiplying by negative, you need to flip the inequality sign. Alright, next example. I have 3x minus 1 is greater than negative 28, and 2x plus 7 is less than 19. Okay, so when you have something like this and you get and, you're going to solve both. So I'm going to add 1. So I get 3x greater than negative 27 divided by 3. So x is greater than negative 9. And let's solve this next one. So I'm going to minus 7. So I have 2x less than 12. When I divide by 2, I get x is less than 6. So here I have x is greater than negative 9 and x is less than 6. Okay, I can rewrite this as one thing like what we had on the front of the notes. So this would be your x is in between negative 9 and 6. So on your graph, you should have it look like this. So x is greater than negative 9, but less than 6. So everything in between those two numbers. Okay? Here's something that you need to keep in mind. So if and, so if we have this and like in our problem, and your graph ends up looking like this, this means no solution. Okay? The reason being is you can't have something that's, let's just give these numbers, 2 and 4. You can't have a number that's less than 2 but also greater than 4. That doesn't happen. Okay, so that's the reason being this is no solution. So look for that in your homework. Alright, down to example 4. If I have 4y minus 2 greater than or equal to 14, or 3y minus 4 less than or equal to negative 13. Alright, again, solve these like normal, so I'm going to just solve these real quick. So 4y greater than or equals 16, so y is greater than or equals 4. Add 4, so 3y less than or equal to negative 9, so y is less than or equal to negative 3. So in this case I have y is greater than or equal to 4, or y is less than or equal to 3. So when I graph this, let's graph this one first. I'm going to go to 4, it's greater than or equal to, and then negative 3 is less than or equal to. So in this case, this is perfectly fine because it says or. So y can either be greater than or equal to 4, or y can be less than or equal to negative 3. So the wording in the middle matters a lot. Okay, another special case with or is if we have, let's say we have x is greater than negative 2 and x is less than 4. This is just, and I graph this. So negative 2, open circle to the right. Then I go to 4, open circle to the left. If you look here, my lines overlap. So basically it includes everything from negative infinity to positive infinity. So if it overlaps and it's or, then this is all real numbers. That's your solution. So when you graph it and you see that, make sure you acknowledge it and write that down. The assignment for this lesson is A3, page 29, numbers 4 through 7, 14, and 43 through 48. Please let me know if you have any questions, and good luck.